What is up, everybody? A very, very happy new year to all of you guys. Thank you so much for making 2014 such a fun, awesome year. And I really hope for all of us that 2015 is just as fun, if not better. And I really, really think it's going to be better. I have a good feeling about this year. So, all that being said, if you celebrated like I did last night, chances are there are probably some photos floating around that you wish you could just blur out of existence. Maybe you had a lot of liquid courage and tore up the dance floor with a middle-aged woman. Maybe your crush got secretly married behind your back and you want to blur everything about his face out of existence, and then maybe we'll see if that skank still likes him. Why would you do this to me, Joseph? What? Or maybe you have a significant other already and you took the perfect profile picture, but they're taking away just a little too much attention from you, and it is your profile picture, so... Or maybe you just want to get this year started on the right track and improve yourself, and learn the invaluable skill of programming. If that's the case, then stick around for a while, and I'll show you how to make your own photo blurring tool from scratch using C++ and the OpenCV library. Warning: this is what I consider an intermediate programming tutorial. That being said, I'm going to try to explain all this stuff in a way that, even if you've never coded before, you can pick up on the basic concepts. If you are serious about learning programming, a little Google searching and some self-research goes a long way in making sure you get the most out of these video tutorials. If you do have any questions, definitely don't hesitate to leave a comment here, on our Facebook page, or on our Twitter feed, and either I or some of our programming fans will get back to you. The first thing I'm going to do is show you how to download and set up the OpenCV library. If you want to skip this part and you're not on mobile, you can use the YouTube annotations to click here and skip ahead. If you are on mobile, you can use the timestamp and it will show you where to skip ahead in the video to get right to the programming. Alright guys, so we're going to start out at the OpenCV About page, and any links we use in this video I'll be sure to post in the description. And I won't read all this to you, but it's a really interesting read if you want to see the history and what OpenCV is all about. I'll give you the too long didn't read version, and that is that OpenCV, which stands for Open Source Computer Vision Library, is an open source computer vision and machine learning software library. Now we're going to be using it for some pretty simple stuff compared to what it's capable of, but all you really need to know is that it's got a lot of optimized algorithms and structures already written to make programming with visuals really, really simple. In that context, it's also really simple to download it. You just go to the download page, which I'll also put in the description. Choose your operating system, and it will give you a nice little executable. What you do want to make sure you do is take note of where you put the directory for where you install OpenCV, because we're going to use that when we set up our environment right now. I am going to use Visual Studio for this tutorial. I am not positive how to set up OpenCV with other IDEs. If you do some self-research on Google, I'm sure you can find some help, and you also might search how to add the OpenCV library to your path variable. If you didn't understand a thing I meant right now, I definitely recommend downloading Microsoft Visual Studio Express for Windows Desktop. It's completely free and easy to download. I already have my picture picked out for this project, so I'm going to go to where I set that picture and just set up my project there. You can set up your project anywhere you want to. I'm just going to call it, you know what, console application 1 is too boring. Let's do phantom darkness _ blurring tool. That sounds much better. And you just want to set it up as an empty project. Make sure that's checked. We'll finish up and we should see a pretty empty screen here. What we're going to do first is go to source files, right click, add, new item, C++ file. And if you're a intermediate programmer, you have some programming experience, you can organize this any way you want to. For the sake of simplicity, I'm going to put everything in one CPP source file, and we'll just call it source is good. Source is fine. And I'm not going to promise that my code is going to be the most efficient or the most neat. All I did was whip this up in like a couple hours, and it's functional. I think it's pretty neat. It's only a couple hundred lines, I think, but I hope you don't, if you do have programming experience, you don't critique me too badly. I apologize in advance. Alright guys, so let's get started setting up our project to work with OpenCV. What you want to do in Visual Studio is right-click your project over here, Properties, and there's a few dependencies we need to set up, and I have them all in a notepad file here, and I'll also put this in the description of the video. If it doesn't fit, then I will make it a link wherever I post the code for this video. Either way, I'll make sure you have all these dependencies and where they go. So this little header here that says include, we need to put these files or these paths into the include directory under VC++ directories. So right here where it says include directories, all you gotta do is put edit, go to your little handy file here, copy, and paste. Oops, there we go. And another one. And this will give us all the OpenCV stuff we need to use. Okay, excellent. You can see it bolded it to show you that it actually changed it. Right here for library directories, we just have one to add there. This one right here. There we go. All right, and then one last thing we need to do is go to the linker, debugging, or not debugging, input, additional dependencies right here, click edit. And this is going to be kind of overkill because we're probably not going to use all these .lib files, but just in case, we're going to put all these .lib files that OpenCV uses, because we are going to use some. To be completely honest, I was going off of another website's recommendation on what to put in these additional dependencies. So I'm not absolutely positive what the minimum we need is. So I usually just include all of these, and most of my, or all of my projects I've compiled using all of those .lib files. So we apply that. Okay, and we should be good to go. I'll just put a little comment here. This is a program to blur your pictures. All right, now that we got all our dependencies set up, we can use the #include to include all the files we're going to use from OpenCV in this project. So the two we're going to use is OpenCV2, and as you can see, if you've set up OpenCV right in your project with all those dependencies we just did, it should auto-complete this for you. So we want hi/hi/GUI.hpp. That's our first one. That has some input and output functions from OpenCV. Next one, OpenCV/cv.h, that has some algorithms we're going to use. And those are the only two includes we need. We do need to put a using namespace, namespace CV. If you've worked with C++ before, you're probably used to seeing using namespace std for standard there, the standard library. We won't be using the standard library too much, if at all, in this project. We will be using a lot of stuff from the CV library, so we're going to put that line in there so we don't have to type CV : before all the OpenCV stuff we use. If you have no idea what I'm talking about, don't worry about it. All you need to know is that that line helps us out a lot to keep our code looking clean. So the core structure of OpenCV is called MAT, and that's short for matrix. Basically OpenCV, and I'll show you a visual of this in a moment. It's not a very good one. It's one I made in Paint, but hopefully it helps to concrete the concept a little bit. OpenCV represents 2D images in a matrix of pixel values. So each pixel has 3 values, a red value, a blue value, and a green value. And all the colors we see on our screens and our monitors are all made up of different levels of red, blue, and green. So OpenCV makes it easy to work with by making this little matrix structure, and it lets us access each of those pixel values so that we can adjust how much red, how much blue, and how much green is coming through each pixel. So we're going to have 4 mat structures. One is going to be called original image. Another is going to be called edited image. And as we go through the project, it'll become more apparent why we have to use so many. Our current image and our circled image. Next, we need to set up some global variables. We're going to have some integers, x.1. We're going to initialize this, and with C++ you can initialize using this form where you use the parentheses. I'm going to initialize them all to -1. So x.2, oops, y.1. And again, I'll explain what these mean in just a second. All right, that should do. If I put this, yep, there we go. And the last thing we're going to do is put an integer called blur degree. And that's going to set up how much we want to blur. We'll start it at 5. That's a good amount of blur. And then we'll have 2 integer arrays. The sum of RGB, we'll make that a 3 integer array. And the same thing, except this one's going to be called average RGB. So one we're going to use for sums and one we're going to use for average. Imagine that. So I'm going to go ahead and save here. So before we go any farther, let me show you this. I'm no artist, but I made a little visual thing in Paint to try to explain this better. So if this white region here is our photo in its entirety, what we want with this program is to select 2 points at the top corner and the bottom corner on the opposite sides. And then our blur degree is going to determine how big this pixel region is. So say we have a blur degree of 3 like this. What it's going to do is whatever region we selected, for every pixel in that region, it's going to take the 3 by 3 area around it. So say this is the pixel we're looking at. It's going to take the average of all its neighbors, and it's going to make the color of this pixel the average of all the neighboring pixels. And what that does is it creates a nice little pixelated blur for us, the same way you kind of see faces blurred out on cop TV shows sometimes. So here's a little representation of what a pixel looks like in OpenCV. Now if you're used to the RGB scheme, you're used to seeing it with the red first, and then the green, and then the blue. However, OpenCV represents color with B, G, R in that order. So it's very important to make sure that you get the order down so you don't adjust the wrong colors. I hope that visual makes sense to you guys. Maybe when we get the project done, it'll make a little more sense. All right, the next thing we need to do is set up some constants. So the first thing we're going to do is make up a constant vector of integers. And if you're confused about the difference between array and vector, or even what an array or a vector is, I highly recommend you research that before going any farther in this tutorial, because we're going to use these quite a bit. This one we're only going to use once actually, but the sum and the average we're going to use. It's going to be a very important part of our program. The one we're making right now, the compress params, is just for OpenCV to use. Oops, I didn't finish my name there. Params. There we go. I can spell, I promise. And I will explain this in just a moment. Alrighty, there we go. So what this does right here is when we want to save our blurred images, we need to give OpenCV some compression parameters. So in this case, this is just a constant in OpenCV to tell it that it's going to be of JPEG quality. And this is the compression level. So 100 means that it's not going to compress at all. If you want 50% compression, you type 50 there. But I'm not going to compress, so I'm going to leave it just like that. Next constant we're going to use is where we're loading our image from. So this is going to be a string. I'll call it load path. And my picture is located, remember when you're programming in C++, you need to use 2 backslashes because the backslash is an escape character and otherwise it will not work. So make sure you use 2 backslashes when you're entering the path here. So my, let's see here, picture is located at Jeff downloads, new project, and it's Washington.jpg. Alright, too easy. And then the next one is going to be our save path. So this is the image we want to save to. I'm going to put mine in the same directory and almost exactly the same. I'm just going to call it something different, so we'll just copy and paste that. We'll call this one Washington Blurred. You can call it whatever you want and you can put it wherever you want. Also, don't feel like you have to go by my style here. I always capitalize and underscore my constants. It is your ball game once you do your project, so you do you. Next thing we're going to do is set up our declarations or our functions. So we're going to have 5 functions here. Blur, which does probably what you think it does. Checkpoints, I'll explain that when we get there. Basically, we want to make sure that no matter where the user clicks, it's going to draw the region right. Blur region. This one's going to have some parameters, so constant in x, constant in y. That x and y is going to be the x and y coordinate where our mouse clicks. So find average. It's going to find the average of something, of course. And finally, on mouse, this is to use with OpenCV. This is going to make sure that the program will respond to our mouse. And once we get to each of these functions, I'll go into more detail about what each of these means and how we're going to use them. So don't you worry. Alright, so there's all the function declarations we need. What we're going to do is make our main function first, even though we haven't defined any of the functions we're going to use yet. And then from there, we'll go ahead and we'll go down this list and define all those functions. So let's get started with main. This is the body of our program. First thing we want to do when our program starts is make sure that the image we're loading from load path actually exists. And if it doesn't, we want to get out of the program and exit. So I'll go ahead and make a little comment here. Exit if image not found. And we'll make an if statement here. Hold on one second and I'll explain all of this. Alright, I cut away so you guys didn't have to painfully watch me type that out and listen to my keyboard tick tick tick. So what this statement does right here in the if condition is it loads using the imRead function from OpenCV. It loads from our load path constant right there the image into our matrix, original image. And each matrix in OpenCV has a data member, and if that turns out to be null in this case, that means that the image we're trying to load from this path doesn't exist. So what we want to do there is print an error message. If you're not familiar with printf, which is short for print format, what it does is this little %s here is a placeholder for a string, and this loadpath.c_str. What that will do is if the image is not found, it'll print to the console error, file not found, and then the path that we use for our load path. That'll show the user what path they used that did not work. This line right here, it just makes it so that the console will pause and not close out immediately, and it will put up a message that says press any key to continue. And this just returns the number 2. That's just an arbitrary value. I think I used return 1 somewhere else in this program, so that's why it's the number 2. That's just the return code from our program. If you're a beginner programmer, typically you want to return 0 if everything is successful. So 2 means that something went wrong. In this case, the file wasn't even found, so we had to quit before we even got started. So once we have that one check there, that means that if we get past that point, our image does exist, and we can now work on getting our environment set up. First thing we're going to do, I want to resize my image. You don't have to resize it. I'm going to resize mine to, let's see here, 800 by 600 is a good size. So this function right here, the first argument is the where you're taking the image from, or the matrix rather, and where you're going to put the resulting matrix. In this case, I'm just moving it from original image right back into original image, so we're going to keep it in the same variable. And we're just going to resize it to 800 by 600 pixels. Next thing we're going to do is copy original image using the handy OpenCV copy to, and we're going to copy it to our edited image. This will make more sense when we get deeper in the program and you can see how all these different matrices are going to interact with one another. So hold off on your questions for now, and we'll come back to that. And then the last thing we're going to do is set the current image equal to edited image. So next thing we need to do is set up our window. We use the name window function from OpenCV. Give it a title. I'm going to title mine blurring tool. Make it simple. And then I'm just going to have mine auto size. What that'll do is if the user drags the corners, then it will automatically resize the picture to fit the window. And then we want to set the mouse callback. This is important because this will make sure that our mouse clicks are linked to our window. We're going to set it blurring tool. This is just the title of your window that you want to link it to. And then the next argument is what function we want to define our mouse movements and what the mouse should do. So you saw that we made this declaration up here for the function onMouse. We're going to use that to control our mouse actions. Oops, there we go. So that line right there, make sure that the function onMouse is recording all the mouse actions for this particular window. All right, you following so far? I hope so. I'm going to take a drink real fast. And we'll continue with the meat of the main function. So with OpenCV, you want to continually display this window until the user presses a key or clicks something. In this case, we're going to make it so that the window displays until the user presses escape. So what we do is set up an infinite loop rather. And what we do is use the imShow function from OpenCV. And the first parameter is blur the title of the window you want to show, and then what matrix you want to show in the window, or what image you want to show in the window. In this case, we want our current image, which currently holds the image as is without any adjustments or blurring or anything else. And so we're just going to display the image to our window. Next thing we're going to do is set up a character. We'll just call it C, and use the function waitKey with the parameter, the argument 1. And what that does is it basically is just continually waiting for the user to enter a key so that the program can respond. Next thing we do is set up a switch condition. So switch on C. If you're not familiar with switch, what the switch line does, please look that up before going further. I'm probably not going to explain it as well as like the C++ reference would, so please look that up. Basically, we're looking at the character C, and we're setting up a bunch of cases for whatever C might be. So, for example, case 27. You might say, why 27? Why the weird number? 27 in the ASCII code is the escape key on your keyboard. So, in the case that C is 27, which is the escape key, so in case the user presses escape, what we want to do is simply return 0, and that will close out our program, and the program will be complete. In the case that the user presses the character, make sure you include the single quotes, R, or we'll just make it in case they hit uppercase R2, so that'll handle both cases. If they hit R, that means they want to reset the picture to how it was before they blurred it. So all we have to do is take our original image, copy to our edited image, and then we'll make the current image reflect the edited image. And we'll reset the points just in case they've drawn any points on there already. We'll reset them. So x.1 equals x.2 equals y.1 equals y.2 equals -1. We're just setting them all to -1. So let's take a step back for a minute and review what we did in this one case. So if the user hits R, whether it's lowercase or capital, we're going to copy the original unedited image to our edited image variable. We're going to set the current image, the one being shown on the window, to the edited image we just adjusted. And then we're going to reset all the points. So when the user clicks on the screen or on our window, it's going to set all these points to a different number. We want to make sure that even if they've drawn something, when they hit reset, we reset all these points so that they're all -1 again. It'll make a lot more sense when you see how the program works in practice. So after you do a case like this, you want to have a break statement, or else it'll just keep going through these statements. In the case that the user presses the I, or we'll say even if they press capital I, what we want to do is, if the blur degree, I is going to stand for increase, so this is if they're trying to increase the blur degree. If the blur degree is less than 5, we'll increase it by 1 by using blur degree ++. If it is not less than 5, then we'll increase it by 5. Alright. And we'll print a little message that says printf blur degree. Let's see, blur degree. And this is another print format case where this is going to be a placeholder here. And then put an end line there and have it display blur degree. So what this is going to do is display a message to the user that says how much they increased the blur degree by. Pretty simple. And then we want to add our break there. In the case that the user wants to decrease the blur degree, if they want a less blurred picture, they hit capital D or lowercase d or capital D. Oops, I need a space there. In that case, what we want to do is make sure that if blur degree is less than or equal to 5 and blur degree, oops, I can spell, is greater than 1, we want to subtract it by 1. And we never want our blur degree to be 0 or negative, so if it's at 1, we want to keep it at 1 no matter how many times the user decreases it. Alright, the last case we need, we'll go ahead and add a break here. Last case we need is if the user presses S or capital S, we want to save the blurred image or the edited image no matter what it is. So we use the IMWrite function. And we save it to our save path. That's the first parameter, is where you're saving to. We tell it what image we want to save, which is the current image. And then we send it the compression parameters that we established as a constant up above. And then we'll print a little message that says, okay, it's been saved to this path. So we'll put image. And in case you're wondering, you have to use that .c_str when you're using printf. Otherwise, if you just use it without it, it won't work. So then we break, and then we have a default case, which is if they do anything else with their mouse or keyboard, or at least with their keyboard, then just continue, and it will just keep looping and looping and looping. And then if we get down here, we don't really want to get down here ever, but we'll just add a return 1 down here. Just in case something goes terribly wrong and the program ends up down here, it will return an error code of 1, which is not 0, so that'll alert us to the fact that something went terribly, terribly wrong. And that's it for our main function. So we're only at 89 lines so far. I'm going to take a sip. Now we can get started with the fun functions. So the first one we're going to make is our onMouse function. So we'll go ahead and type out void onMouse. Actually, I'll just copy it from above. Make sure you don't include the semicolon. So all these parameters up here are required for the OpenCV library. So the event is the mouse event. The X is the X position. So if you imagine your screen is a big coordinate system, X goes positive this direction, Y starts out at 0 up here and goes positive in this direction. So the X and Y capture what point we click on. So the flags you don't need to really worry about for this program, and the user data you don't need to worry about for this program. All we're really concerned with is X and Y. And the event, actually, because we need to know what kind of mouse action they took, whether it was a left click or a right click or a movement. In this case, we'll just be using the left click. So to do that, we put if event equals event L button down. So this means not that they've clicked, but that they've pressed the left button down, so they haven't released it yet. So I'll just add a little comment, left click. So if they click on the screen, we want to capture that so that we can make our region. So edited image.copy2. What we're doing here, well, I'll explain when we finish everything so I don't have to stop at every couple seconds. Alright, so let's look at this. So the first thing we're going to do when they click is copy the edited image over to circled image. Because when we circle the image and we're going to put a little red dot where they clicked so they know where they clicked. And we don't want that to end up on our final image. We don't want a bunch of red dots everywhere. So we made a separate matrix to hold the circled image. And then to add a little circle, all you gotta do is use the OpenCV circle function. Give it what image you want the circle to end up on. The point, so where they clicked, is going to be point X and Y. This is the radius. We're just going to make it 2 pixels wide. Scalar 00255. This is the color, so it's going to be a red circle. Again, like I said earlier, OpenCV does blue, green, red. So by putting 255 in the red slot, that's a full red. 255 is the max number you can have in there. So that's a full red circle. This is the thickness actually, but when you use a negative thickness, it'll fill the circle. So if you have a positive thickness, it'll be a hollow circle. In this case, I want a filled circle, so I made it negative. This makes the current image equal to the circled image, so that when the loop goes around, the circled image will be the one being displayed to the window. And now we can set our x.1 variable to x, this x right here that's being captured, and our y.1 variable to y. Oops, I had to make a little correction there. We want a separate block within this if statement called if x.1 equals -1. And why we do that is because when the user clicks, what they're doing is x.1 and y.1 establish this point right here at the top. x.2 and y.2 establish the opposite corner. So if they haven't clicked yet, that means that they don't have any circles on the screen. And how we test to see if they haven't clicked is x.1 should be equal to -1. It shouldn't be equal to any positive number. Otherwise, that means they've clicked on a region already. So we need to handle the case where they have clicked already. So that means they've captured their first point. So we'll make an else statement. So once they click their second point, we want to erase the red circles we've made on the image and blur the region they've selected. So that's what we're going to do. We're going to make the current image equal to edited image. That'll make sure all the red circles disappear. We want to capture x.2 and y.2. Oops. And then we want to check the points. I'll explain that function when we get to it. Basically, we're just making sure that the user, no matter which way they click, the region will show up correctly. We want to blur that region. And then we want to reset all the points so that it's like they haven't clicked the picture yet and there'll be no stray red points anywhere. So we're just resetting so that we can tell that they haven't clicked yet. Beautiful. Alright, and then we can finally put our end bracket right there, and that does it for on mouse. Alright, so now that our mouse function is set up, let's take a look at this mysterious checkpoints function. So, checkpoints, let me type it out right here. It's a void function, and it's a very simple one. If x.1 is greater than x.2, what we want to do is swap them. So we use the std : swap. And all this does is, this is from the standard library. It's a function from the standard library. And what all it does is switch out the values of two variables. So it's going to switch whatever's in x.1 with whatever's in x.2. You may be asking yourself, why would we want to do that? Give me 1 second and I'll explain. And we want to do the same thing for y.1. Oops, I need a parentheses there. And that's all we really need for that function. Oops, I need to fix that though. And we're done. So what this is doing is, in a perfect world, the user would abide by our rules and how we want the program to work, and they would select a region from the top left corner to the bottom right corner. However, what happens if a user starts here and wants a rectangle from here to here, or from here to here, here to here, and all that? They're going to click all over the place, so we want to make sure that, say that, so x.1 is greater than x.2, that means that x.1 is over here, so their top corner's over here, and their bottom corner's over here. We want to reverse the coordinates of those corners so that the region shows up correctly. It'll make a lot more sense when we do the demonstration how this function helps us out. So let's move on to the big part of this program, the blurring. So give me a second to type this out and we'll go through what each part means. Alright, so this is our finished blur function. It probably looks a little confusing right now, so let's dissect it a little bit. The first thing we're going to do is set up a couple for loops to loop through each pixel in the region we've selected. So say our blur degree is 3, this is what our region is going to look like. So let's say we start at the first pixel and we're right here. This is the pixel we're looking at. So we're going to find the average of the surrounding area. That's what this function right here does. And then we're going to blur just this 3x3 region. And we're going to repeat that from where we started, this point right here, to the end of the region right here. So it's going to go across this region like this, down to here, and it's going to keep taking these 3x3 pixel regions, and it's going to blur each one individually. If the blur degree was 5, then it's going to go to every 5 pixels and just go, okay, here's 5 pixels, take the average, make this pixel the average of its surrounding neighbors. Okay, hop over to the next square. This is the next 5x5 region. Do the same thing, all the way down to the end of our region. Again, probably make a lot more sense once we do these other functions and you can see it in practice. So let's get started on the blur region function. Actually, since it's first, let's do find average first. Alright guys, so this is the finalized find average function. This is probably the most complex part of this program, so I'll try to take it slow with the explanation here. So, and I think I misspoke earlier. I said that we'd be looking at this pixel and taking the neighborhood around it. It's actually, we're going to be looking at this pixel in the top left and taking the neighborhood of the box around it. So it's just a minor correction. It won't affect our code, but I think I misspoke earlier and said we'd be starting here in the middle. We're actually starting up here. So let's take it little bit by bit. So find average, we send it the x and y coordinates of this part of this pixel right here in this 3x3 region. That's assuming that our blur degree is 3. If our blur degree was 5, then we'd have a 5x5 pixel region. But let's keep it simple and say we have a 3x3 region. So we start here, and these first two for loops just make sure that we get through the whole square. And what we're doing is we're taking this sum RGB array, and we're making it so that the 0th element of sum RGB is the sum of all the blue values in each of these pixels. Same goes for, so the first element of the sum RGB is the sum of all the green values, and then the second element is the sum of all the red values. So we're just adding up a sum of each of those individual colors in each of these pixels in the 3x3 region. So let's take a look at this right here. First I should explain what this if condition is. This if condition here is just checking to make sure that we're not going out of bounds of the image. So we have an 800 by 600 image. If we have, so say we're at the very edge of the image and we try to add 1 to it, we're in 801, that's outside of the image. So we don't want that because we can't work with something that's outside of our image. So this is just a check to make sure that we're working with pixels within the image. So let's take a look at this right here, because this is probably going to be the most complex part to understand. With OpenCV, how we get the individual colors from each individual pixel is we have to use a pointer on the image and take out each of the red and the green and the blue. So this is our image right here. We're going to set up a pointer. If you're not familiar with pointers, definitely go and research those first, because it's going to be even more so difficult to comprehend this part if you don't know how pointers work. What we're going to do is set up a pointer, and we're going to make it a pointer to an unsigned character. And the reason we do that is an unsigned character is exactly 256 bits. The most it can be is 256 bits. And we do that because we want values between 0 and 255. That's how we represent our colors here. The minimum you can get is 0. That means absolutely no blue. If we have 255 in blue, that means we have maximum blue. So that's why we use a pointer to an unsigned character. This part is, if you're familiar with two-dimensional arrays, it's sort of like that. What we're saying is for each of these pixels, so from here to here and here to here, all these in the square, we want to take 3 times, the reason we do 3 times x plus j is because the way the matrix structure is set up, this is going to be really hard to try to describe in words. Let me see if I can pull up Paint and try to explain it that way. It might be a little easier for you guys to comprehend here. So here's our matrix. That's a beautiful matrix right there of an image. here's all the pixels. And these pixels are further subdivided into 3 different regions for each color. So this is blue, this is green, and this is red. That's why we have to multiply. So when we travel through the matrix, we're going one by one, not by pixel, but by color. So when we need to skip over to get to the next pixel by 3. So that's why we multiply it by 3. I hope that makes sense. Basically, we multiply it by 3 so that we can skip over the colors of this pixel, move to the next pixel's colors. Otherwise, if we didn't multiply it by 3, we'd be moving through each individual color and recording the wrong thing. It's a terrible visual representation. I hope it makes sense to you guys. Please leave me some questions in the comments if you need some further explanation. So what we're going to do is we're going to go loop through all in the neighboring region. And we're going to take the red, we're going to store it in here. Here you see we add 1. And that's because we need to get the next over, which is the green, or I'm sorry, I said red for this one. I keep mixing that up. This is the blue, this is the green, and this is the red. So we're just summing up the blue, green, and red of every pixel in our blur region. After that, after we get all the sums, after all these for loops, we set up one last for loop, and we store the averages in average RGB. So average RGB just holds, I guess I should have named it BGR actually, but anyway, average RGB holds the averages that we need to set the color for this pixel. So all we do is take the sums, so the sum of 0 would be the sum of the blues, divide it by the blur degree region squared, so that's by 9, so 3 times 3, 9. So that's the average of all the blues in this region. Whew, that was a mouthful. I hope that makes sense to you guys. Basically taking the averages, I've said it many times enough. If you guys don't understand it by what I'm saying now, me trying to explain it even more is not going to help at all. So hopefully you guys can understand. If you don't, please, please, please ask questions. That's the only way you guys are going to comprehend what's going on here. So we're almost done, guys. We have one more function we need to do, and that's to do the actual blurring. And what that consists of is just setting each of these pixels equal to the average of their region. So what we're going to do is make our void blur region. This is going to do the actual blurring. We're going to also send it the X and Y coordinates of the pixel we're looking at. Give me 1 second. Whew. Alright guys, final function, here we go. Blur region, let's dissect it a little bit. So we cycle through in a very similar way to find average, except this time the difference is we're not going to sum up the colors of each pixel, we're going to assign the pixel's color. So say we're on this pixel, we're going to take the average blues, which are being held in average RGB 0, and we're going to set the blue value of this pixel to the average of all its neighboring pixels. And this is going to create that nice pixelated blur effect that we want. Same goes for green. Make sure you're adding 1 to the X and make sure you access the right one. Same goes for the reds. And that, my friends, is the end of our program, believe it or not. You may be, I hope you're not totally lost and just like, are you serious? Is this supposed to work? What is this even doing? So let's run it, and hopefully this demonstration will clear things up a bit. Hopefully it will compile, first of all. And it doesn't. There are errors. Oh no. What are the errors? Okay, it's just something small up here. Oh, I know what it is. C string, or C underscore str, is a function. I forgot to add the parentheses there, and there's one more place down here that we need to do that. Whew, that scared me. I thought it was going to be something worse. Looks good so far. There we go. So I selected a picture of myself with the father of my country, George Washington. I was ecstatic. He was not as excited, but I'm sure he's holding it in. Anyway, so let's select a region. So we saw our red dot up here. That's a good sign. That means our circle function is working. That was a poor region though to select, but that's good because we'll get to use our reset button and see how that works now. But you can see up in the trees a little bit that the blurring actually did work. So let's reset using the R key. We see that it works. That's perfect. So let's say, let's go over checkpoints, because I said earlier on that it would make more sense once we did the demonstration. I hope this clears it up a little bit. So if we had omitted the checkpoints function, our user could easily blur faces by doing left to right clicking to establish a region. But we want the user to also be able to select from right to left because this is a free country and they should be able to. So by using checkpoints and swapping out those two numbers, the two coordinates, we can make sure that no matter what way they establish the region, it'll get blurred, whether they click from left to right or the top right corner to the bottom left corner. So we see that the blurring is definitely working. Let's try to increase the blur degree a little bit. Right now that's 5 pixels. So let's make it bigger and then we can kind of examine what's going on. So let's do 20 pixels. That's really blurry. So we can see here that just like this little diagram, except in a much bigger scale, what it's doing is it's starting at the pixel right here. It's very tiny. You can't see it in a block of 20 pixels. It's taking the average of this box of 20 pixels and it's making this whole region the average color. And that creates that nice mosaic, almost pixelated effect that we see here. Sorry, I had to cut away for a second. I just realized we forgot to put a little message on the decrease to make sure that it tells us when we decrease it. So let's make sure at the end of this we say blur degree decreased to blur degree. There we go. That's all we need to do. Let's recompile. Here we go. So let's try to decrease the blur degree. If we put it down to 1, we can see that it doesn't go below 1, which means our checks are working. That's great. With the blur degree of 1, you're not going to see too much pixelation at all. If I do it over my eye or my face here, you can barely tell it's being blurred, but it is being blurred. If we increase it up to 2, maybe you'll see it a bit more. So you can see it a bit more in 2 pixels, a bit more in 3, 4, 5. So you see how this works. So we can reset. Let's just do a nice typical face blur right here, and we'll hit that lady back there too, and this guy, why not? So now let's see if our save function is working. We press S, image save to that path. Let's go to that path. And we see that we have a JPEG of our blurred picture. Alright guys, that is all she wrote. Man, that was well over 2 hours of raw footage here. I'll cut it down for you guys for sure. There's a lot of corrections and typing I had to make. But I hope you guys enjoyed this. I hope that if you're learning programming or if you're an intermediate programmer that this was beneficial to you, especially if you're interested in working with visual stuff. I'm not promising that this is the cleanest way you can do this. This is we got to 174 lines, which is not bad, but with a little cleaning up, you could probably get it down to even less than that. So I definitely invite you, if you're a programmer or even a beginner programmer who wants to tinker a little bit, take this source code. I'll post it online. I'll put a link in the description to this video. Run it, tinker with it, play with it. Just learn as much as you can, and I hope it's helpful to you in some way. I had a lot of fun making this. I'm completely out of a voice now, but definitely worth it if you guys took something away from this video. If you do have questions, please do not hesitate to ask. If I'm away from my inbox, hopefully maybe some of the programming fans out there can help you out in the comments. So please put your comment out there so that all of us can see it and help you out. You can leave it in the comment for this video, on our Facebook page, on our Twitter feed, whatever you need to do. I just want to make sure that you guys, if you're learning how to program, I want to give you guys the best tools and the best explanation. Not always great at the explanations or the art, as we can see here. But I hope that I explained it well enough for you guys to grasp the basic concepts behind how this all comes together and creates that nice blurring effect. Yeah, I hope that your new year is everything you want it to be and more. We'll get back to games starting tomorrow. And for now, I cannot thank you guys enough again for joining me for all of 2014. It was a great year for this channel, and it's all because of you guys. And looking forward to 2015. But for now that we've created this cool tool from scratch, I am Phantom Darkness 135. I am out of a voice. I need to go get a drink. I am out of here. Have a wonderful night and New Year's, everybody.